In this video, we are going to be do a few basic operations with polynomials. Specifically, we're going to add and subtract like terms. So what does it mean to be a like term? So we're going to go through a couple problems of just looking at these of what are like terms or not like terms, and then we'll add and subtract. But basically, with like terms, you're looking for where you have the same variables and the same exponents. So you're looking at an a squared and an a squared and a b and a b. So those match perfectly. So then you would be able to add the coefficients in front of them. Okay, we're not doing that on this, but basically, yes, they are like terms. So you would be able to add or subtract. Here, the x's don't quite match. They're both x's, but it's an x squared versus an x, and then the y's don't match. So they are not like terms. We would not be able to add them together. Here, this one's a little tricky because this needs to be kind of worked out first. We need to square all the pieces on the inside. So we're going to square that, square that, square that. So if you take -2 and square it, that gets you a 4. If you take a and square it, it's a squared, and b and square it. All right, so now we're really kind of comparing these two. Well, they were good with the b's, but the a's don't quite match. So they're not quite like terms. So we won't be able to put them together. So no. And then here, it doesn't look like they would go together, but actually this one is not in the same order as this one. I like to put things kind of alphabetical regardless of the powers on it. So if I did it alphabetical, I would be rewriting this as -2x to the 4th, y to the 3rd. Now I can kind of compare a little bit better, apples to apples-ish kind of a look to it. So you have x to the 4th and y to the 3rd. So yes, you'd be able to combine the value, the coefficients in the front. So yes. All right, and then the last one of these is a no, because x squared and x to the 3rd are not the same. So as far as adding or subtracting, you would not be able to put them together. So they're not like terms. All right, so a couple examples of combining some like terms is exactly what the other problems were, is you're looking to see if the variables match. And if they do, then you're adding the coefficients together in front. So you're looking at a 7x to the 3rd. Notice how the x to the 3rd does not change, right? If you have an x to the 3rd, it's like having a common denominator. That's what allows you to add the numbers in front. All right, so over here, you have x to the 5th and an x to the 5th, so you can be able to put these together. So it'd be a 1 minus a 4x to the 5th, which would get you a -3x to the 5th. And then the third one, here we're looking at what can go together. We can put the a to the 3rds together. So that's a 1a to the 3rd plus a 3a to the 3rd would get you a 4a to the 3rd. And I like to kind of cross things off to know I'm done with them and see what's left over. So I have a squares that'll go together. So 4 minus 6 would be -2a squared. All right, and then those wouldn't be able to go together any further. They're not like terms. And then with the letters, you have m's that would go together and the n would not. So it'd be a 3m minus a 1m, which would get you 2m plus the 5n. So the m's would go together and then you'd have left the 5n. And then on this one, we're going to start with the highest power, kind of work our way down like we did with the a's. So you have a y to the 3rd, which would not go together with anything because there are no other y to the 3rds. Then you'd have a -5y squared. And then we could put the two y's together. So there'd be a 1y plus a 1y, which would make a 2y. Okay, then we have 2 more examples. This one involves subtraction. So we're still going to look to combine like terms. They're really going to look just like the other problems, just more pieces. But you do have some parentheses, and the parentheses kind of scream distribution to it. So that is a -1 that we need to distribute into both of those. So once you do that, all that's going to happen is the sign's going to change. So these two don't change because we didn't distribute anything into them. But this would become a -3y squared minus a 5y. And then it's exactly the same as the last problem where we're just going to combine our like terms. We'll start with the highest power, which is the y cubed. There aren't any other y cubes. So that would just be a -3y cubed. And then we'd go to the next power down, which is a y squared. And then the next power down, which would be a negative 3y when you put them together. All right, and then the last one. The last one has two sets of parentheses because it's the idea is that it's this expression minus this expression. So you're combining like terms. This is just kind of an organizational thing initially. There is nothing to distribute into this one, so I can just rewrite it. Minus 3m squared minus 5m plus 4. Now the other piece, though, is just like this, where you have a negative that you need to distribute in. So that negative is going to distribute into each one of these, which all it's going to do is change their signs. So this will be a minus 4m cubed. This will be a plus 2m squared plus 5m minus 2. And then we'll combine our like terms. So we have m cubed and a negative 4m cubed, which would make a negative 3m cubed. So those go together. We got squares, so that's a negative 3 and a positive 2, which would make a negative 1. So you can just write it as a negative m squared. And then, so those would go. And then you got a negative 5m and a positive 5m. They totally cancel each other away. I guess another way to write it would be a 0m, but you really don't want to write that because 0 times anything, it's going to make it go away anyway. So those just cancel each other away, and you're left with a 4 and a minus 2, which is a plus 2. Okay, and that was adding and subtracting like terms and recognizing like terms.